Hi everyone. This is the Workspace.com, which is a simulation for our electronic circuits. So it works on the web and it's easy to use. So in this video, we will see how we can blink an LED by connecting it to the digital pins of the ESP32 microcontroller board. As you can see, if you come on the Workspace.com, there will be different microcontroller board that you need to select. So in my case, since I'm using the ESP32, so I will click on that. After that, you need to click on this starter template, which is shown by the ESP32. So as you can see, we have our sketch.ino, which is where we write our code, which is on the left side. And there are options for library manager as well. If you want to install library, then you can click on this plus button and install that specific library. Come on this sketch.ino and you will see it gives us a sample code. And on the right side, we have this simulation where we have this 3 buttons. One is for start simulation. Second is to add parts or components. Third is if you want to use zoom feature, toggle, full screen, etc. And finally, we have this microcontroller board. Okay. You can zoom in by scrolling from your mouse, or you can do it from here. Now, you can see this are the pins, and as I hover over it, it will show you the pin description. Now, let's write our code on the left side. So let's connect an LED to the by LED equal to 12 on the digital pins, which is 12. So in order to add the LED, you click on this plus icon and then search for LED. You can see this LED is popping here. So if you click on this, then the component or the LED will be shown here. Now, you can change the color of this individual LED. Now, since you know there are 2 terminals for an LED, one is anode and the second one is cathode. We will connect this anode to this digital pin 12. But we will need one more component, which is a resistor, to limit the flow of current through the LED. So I have placed this resistor in the same way as we did for the LED. I will place in this way. As you click on this, you will see that you can also change the value of this resistor. Let's say if I change it, write it at 500 ohms, you can do it in this way. So you can see the color changes to green, black, brown, which is the color code for the 500 ohm resistor. Now, if you come to one of the terminals, you will see it highlights in a green box. Now, left click on that and left click where you need to connect it on the other end of the pins. This way you can connect the circuit. The cathode will be connected to ground. Also, since We can even change the color of this wire by clicking on this palette and selecting the black color. So this is how our circuit will look like. Let's come to the programming part. Now I will select the baud rate as 9600 in this void setup, and it will print hello ESP32. Okay, so in the void setup, we have to um declare this LED as an output. In that case, we write pin mode the LED as output. Now in the loop, we will write the main code. So I want my LED to blink for in an interval of 1 second. So I will write LED high, and after that I will add a delay of 1 second. Same digital write LED low and a delay of 1 second. So this is the command. You can add the command like LED is high, then we have a delay. Delay of 1 second. After that, the LED is pulled low. So this are the comments which we are writing, and then we have a delay of 1 second again. Okay, so we have completed our code, but first thing you need to save this project. So on the top, you can see there is a save button. You just need to click on this save, and let's write it as LED blink. And then you have to give the project name and then click on this save. After that, once it is saved, you can click on this start the simulation button. After that, the project will start compiling and upload the code. So if you can see, the LED is glowing. And on the bottom, there is a serial monitor where it display hello ESP32. So this is how you can perform the LED blink operation in the Workspace simulation. You can even stop the simulation from this button. Thank you.